Hello and welcome to this video. In this video, we will learn about queue data structure. So if you have watched my previous videos on linked list, then there'll be not much new in this. So queue is a very useful data structure to simulate real life scenarios, or in general, when we want to have first in, first out operations on a sequence of data, then queue is very useful. For example, you want to perform transactions or you want to process stuff in order, then queue is very useful. So we have a structure here, queue, which has the data portion. You can replace this with anything. The second part is not replaceable, which is the next pointer of the same type, that is struct queue. We have head and tail as convenience global variable. A queue has two operations, enqueue and dequeue. Enqueue will take tel pointer and the data, and dequeue will just take head pointer to dequeue from the beginning. So in a queue, you append at the end and you remove from beginning. So a linked list typically does not have a tail pointer. The semantics of linked list is that you have only head pointer. But if you have only head pointer, you can't append at the end. There will be O operation. So to append at the end, we have a tail pointer. So it's a linked list with a tail pointer and head pointer. Usually it is convenient to have a tail pointer on a linked list because it makes the append operation O1. In a queue, both enqueue and dequeue operations are order 1. So let's see the implementation of this. So we have our main program, we have a menu, which is you enter 1 for enqueuing and 2 for dequeuing, enter any other number or digit and we will bail out. So if it is 1, we enqueue the red element from keyboard, and in case of dequeue, we dequeue. Note that we are passing tail and head as pointer to pointer because we want to modify them. Let's first see enqueue. Now you pass the tail pointer and you have data. When I say pointer, it doesn't mean one star. It is a pointer to pointer, just shortcut to say pointer. So we have data, we allocate a temporary variable, and if that is null, that's a memory allocation failure, and we bail out because there is no easy way to recover from memory allocation failure. If the allocation is successful, we point the next to null and we copy data to the data part of the temporary allocated memory location of queue. Now there can be two cases while you are enqueuing. The first case is the queue is empty. So in that case, this head and tail pointer both will be null. So we point both of them to temp. That's it. But the second case is queue is not empty. In that case, what we do is the next pointer of tail, which is null, we point that to temp, and then we move the tail to point to temp pointer. So the tail next will again become null because after this operation, tail is nothing but temp. So in this case, tail will become temp and the next will be null. So the tail's next is always null. That's where you append the element. Now in case of dequeue, there can be three cases. First is that the queue is empty. If the queue is empty, we return -1. More on that later. This -1 is very important. The second case is there is exactly one element, that is head is equal to null. So in this case, what we do is we have a data variable. Over there, we copy the value of head data and we free the head pointer and we set both head and tail to null. But if there are more elements, that is more than one element, then what we do is we have a temporary pointer where we store the head's value. We copy data to head pointer data, head's data, and we move head to point to the next element. And then we free the temporary variable which holds the address of head. And then we return data. So let's see this in action. So we compile using our standard flags. Okay, so we have problem on line 27. I was editing the code, so problems are kept. Okay, this should work. Now we run this. So first we try to dequeue an empty queue. Right now queue is empty, so if we dequeue, we should get -1. We get -1. Now let's enqueue 3 numbers. So we enqueue 1, we enqueue 2, and then we enqueue 3. Now our queue has 3 elements, 1, 2, 3 in that order. Now if we dequeue, we should get 1, 2, 3 in that order. So let's dequeue. We get 1, we get 2, we get 3. So we got 1, we got 2, and we got 3. Now if you further dequeue, we should get -1. So we got -1. That means queue is empty. So let's bail out. So looks like the program is working. Now we come back to one of the most important things which people generally don't consider at all when writing simple data structures. The problem in this whole program is this guy. The problem is this data is of type integer, and dequeue should return that integer, the element dequeued. But since the data type is integer, this -1 will mean that an enqueued element -1, because you can enqueue a -1, and when you dequeue, when that element will be dequeued, there is no way to differentiate whether the queue is empty or the element dequeued is -1. So this is a big problem over here. Now suppose you have a structure here, or a pointer to structure where you hold the data. Then in that case, you will usually want to return null here. Okay, and here you will return structure, and that is a value of structure. But in this case, it will be null. It's a big problem. So suppose this is a float. Okay, it's a float. Then in that case, dequeue will return float. Now in the float, you might want to return -1. Again, you won't know that an enqueued -1 is dequeued or the queue is empty. So how do you resolve this problem? So you should pause the video and think about how to solve this problem. Here is my solution. So what I do is I pass a pointer bool rcode with value false, and here I will set it to false. Okay, and here I will set it to true, and here I will set it to true again, or you can simply set it over here once. Now in this case, before examining the int return from dequeue, I will examine the rcode. If rcode is false, I will know that the queue is empty, and if rcode is true, then I will know that it's a dequeued element, and only then I will use that value of the dequeued element. So this is one neat trick which people miss when they're writing the queue interface. There are more solutions possible. One of the other problems we have is that this queue is not a generic queue, but C does not allow generic programming. So you use hacks like macros to make a queue which is generic. So maybe sometime later I will come on to a generic queue which can take any kind of element and enqueue and dequeue those. So this is where I will end this video, and in my next video I will show you doubly linked list. And if you find this video useful and informative, then please subscribe to the channel and like the video so that it can reach more people and more people can benefit from this, because that's how YouTube algorithms work. When you like, it is shown in many other videos, suggestions or search results. And that's it for this video. I'll see you in the next video. Happy programming. Enjoy.